Hi. All right, so to continue on with our learning, our last session before the break is on excellence in mine development and digital transformation. And I'm proud to bring to the stage Don Larson, Manager of Digital Transformation with Epiroc. Thank you.
Well, hello. We have a small, intimate group, but I promise you we'll get through some really good information in the next 15 minutes. I'm sure you're all aware of Epiroc as a world leading OEM for mining and construction equipment. But about 5 years ago, Epiroc saw a need with our mine customers to deliver more value to them, to really help them, monitor and measure and leverage the data and information they had in their mine. And so they undertook to find and acquire several of the world's leading software technologies, enterprise software platforms, and automation technologies. And so in the last few years, you've probably heard in the news that we've acquired over 25 of those software and technology companies. So I'm excited today to talk to you a little bit about that. Just got to grab my... Nope. Can't find the... There we go. So to talk to you a little bit about some of the transformations that are happening in mining as a result of digital solutions. So as a result of purchasing these and acquiring these software companies, Epiroc had three values that all the software technologies had to adhere to. One, they had to be OEM agnostic, work across all mixed fleets. Two, they had to be technology agnostic. They had to work with mines' existing software technologies and infrastructure and softwares that they were using already. And three, they had to be scalable so that mines could implement in step changes, easily adopt, and then move on to scale as the mine grew and expanded. So EY did a study last year and they surveyed mine management and CEOs, and they found out that 41% of mine CEOs globally think that their companies might not be economically viable within the next 10 years if they stay on their current path. And there were several studies by Global Mining and a McKinsey report that said just as of last year, that there's a 25% decrease in productivity across the world. And so it's obvious that our processes and solutions that we've used in previous years are not going to work for us in our best advantage moving forward. And so we have to look for other alternatives. And definitely digital technologies answers that dilemma. And there's many mines across the world that I'm going to just highlight some of the exciting transformations that they're achieving. So for example, there's AngloGold Ashanti is seeing an 18% increase in production, the 7% increase in mucking rate with Hut Bay Minerals, a 60% increase in utilization with Cuiabá in Brazil, a 20% decrease in planned variability with Agnico Eagle, a 50% decrease in electrical usage with Boliden, a 21% decrease in heating costs with Boliden, 21%, sorry, and $75 million recovery in loss with the zinc mine, and $1.8 million recovery in lost revenue in production. So those are just some of the exciting stats that mines are seeing. Those are transformational numbers that we're seeing in mining who you're using and implementing digital solutions. So exciting times. Now, Epiroc has multiple software that I'm not going to be able to talk about today. It takes a week in a conference to cover all of the solutions, but we've kind of divided them into these value chains: connect, plan, operate, protect, automate, and sustain. And I'm just going to talk about a couple of these areas. In connectivity, it's the central nervous system of any mine, modern mine, and we call it the fourth utility because it's that important. We've acquired two companies that focus solely on building robust communication architecture in mines, and really focusing on having the right design both for surface, underground, or a combination of both. And connectivity brings real-time data, it brings collaborative decision-making, and it brings the ability to have autonomous control and monitoring in a mine. But one of the biggest problems I see was I'm traveling, I visited 60 mines in the last 6 months, is that many mine management sort of underestimate, undervalue, and definitely underinvest in their mining communication infrastructure. And so we have infrastructure audit teams all over the world in every country that go to mines, help support them in understanding what their digital needs will be, both in the short term and in the long term, and really helping them design robust infrastructure into their mines so that they have that capacity, both short term and long term, but they have the capacity to put that data transfer to make sure that the right people get the information, that they know where data is being pulled in the mine, and most importantly, that they have that plan for how they're going to support short term communication infrastructure in new development areas and things like that. So case in point, there's a Canadian nickel mine, they put their infrastructure in 7 years ago, and systematically they're adding application on application, planned or unplanned, I'm not sure. But anyway, they came to us, all of a sudden they added a FMS, a fleet management solution they really needed, but it crashed the system. So they're at a standstill. They need this application. Their infrastructure is not going to withstand it. So they come to us at Epiroc, and we were able to provide them a solution that gave them, the ability to run this FMS solution, but it kind of bridged the gap between the old infrastructure. And they gave them a couple of years' time so that they could obviously have that $2 million budget so that they could enhance and build up on their infrastructure. But that's how critical it is, and that's how it gets to is without that infrastructure audit, you can't plan, and applications and silos within the mine start adding applications, and then you get to that crash, which is usually unexpected. And we're going to talk about planning right now. There's quite a few reports online, McKinsey is one of them, and they'll say that the highest value that, if a mine or when a mine implements digital technology across its whole value chain, one of the significant things is that they think that mines will be able to recover $375 billion in revenue that they would lose otherwise. And the two areas are planning and operating. So in planning, Epiroc has, to the best of my knowledge, one of the world's only interoperable enterprise software solutions. So it is able to integrate and assimilate all data from all areas of the mine. So all your OEM equipment, your telemetry, your sensor data, your environmental sensors, all of that information, your geoscans, all of that information, it can collate in one data store. And then it can give the mine management one version of the truth. It provides accessible data for all mine management, and it provides it in a visualized format, spatial data, both 2-dimensional and 3-dimensional. But you can take that information and it can be stored in data lakes or warehouses, or used for more advanced analytics or optimization software platforms. But it really gives this space where you can, house geological data, mine schedules, mine plan, life of mine, midterm, short interval control plans. It can push that information out in work orders all the way to the cab of the operator's equipment, and provide them real-time direction and what to do, and quotas and deliverables. But it also gives that operator that opportunity to, in real time, report data like breakdowns or delays, or amount of consumables used, meters drilled, and it provides that real-time information to mine management so that they can make real-time decisions within the shift to save the shift, or redeploy assets from underperforming and overperforming areas. So it's very, very powerful. And It also in this interoperable platform, there's a digital short interval control. And again, it's bringing that information from the life of mine midterm right down to the operator in the cab. And just one of the success stories is Rosh Pina. So they implemented this integrated mine planning across their mines, and they achieved huge success. The one thing was that they were able to break down the silos of the mine and operate the mine in one central office. And for them, their result was that they've shared with us was their dilution rate went from 20% to 11%. And over the time that they implemented the integrated mining platform, they were able to achieve a record production year over year for 3 years. So that's pretty powerful and very transformative. And Sylvania-Stillwater, what they found was that, a lot of times they're having delays and there's a lot of replanning that has to be done. And with this integrated mine planning solution, one of the superpowers is that mines are able to plan and replan in record time. As you know, it takes weeks to months to, replan. And with our interoperable software platform, it can be done in minutes, and it also can have, very many scenarios of the mine plan for management to choose the best solution. So with Sylvania-Stillwater, what they found was that having that integrated mine plan really, took away the silos in the mine, and it gave them a really united way to do the planning for the mine. And one of the other things in Sylvania-Stillwater was that they have a lot of, problems with, say, operational consistency in terms of the rock mechanics or seismic activity change and interrupt the production. And so they're constantly forced to replan. And so having a solution that allows them to replan very quickly really helps them be, able to be proactive in their decision-making and their plan execution. And one of our Canadian mines came to us, and just to get this right, they were achieving erratic metals mined. So their achievement was anywhere from 40% to 130% month on month. So we proposed integrated mine planning and digital short interval control. And it was within a year's time that they saw a $1.5 million benefit to the company with a 2-month payback. But the real benefit was, obviously they had improved spatial compliance, and the content mineral that was going to the plant was much more consistent. So again, very easy to see some quick transformation within a year of a mine implementing some digital solutions. So one other part of this interoperable software I wanted to talk about, there's many elements of it. I've talked about integrated mine planning. I've talked about the digital short interval control, but there's also stockpile management, there's drill optimization. But I want to really talk about sort of an integrated master business scheduling. So this solution that mines are using it can integrate all of the mine schedules from every division: maintenance, planning, construction, HR, and it doesn't matter the software that they use to do their scheduling, it actually can integrate all of their software and their schedules in one version, and it can help the mines by deconflicting the schedule. And what this really does for mines is it gives them the ability to take an already well-planned mine plan and integrate all of those, schedules from construction and the geomechanics, the planned maintenance, all those tasks for mobile equipment and plant and the shaft. And so now the mine managers can see the impact a month out, and that they can plan around that. And it really, one of the things that happens is that, you no longer have this reactive competition for resources because you're planning a month out and you have this schedule. It gives you suggestions on how to deconflict the schedule. And so you're using this master business schedule, and one of the key things that I really admire about it is it uses standard operating procedures and builds that mine intelligence into something we call standard work packages. So mine planners can use these standard work packages, and people know exactly sort of the work sequence and what's going to be involved and how much fuel is going to be used and how many man hours and the energy required so they can kind of do the logistics and the supply chain. And then we can also kind of add in our environmental management, social governance values to all of these processes within the work packages. So really powerful solution and a quick solution because it's in these standard work packages that you can build out workflows and scheduling very quickly. And it allows the mines to have the right equipment, the right people in the right place at the right time. And these work packages have a lot more benefits. We heard today about the employment shortage. Again, I've been 60 mines in 6 months, and that's a big issue and across a lot of mines. And the ability to have these standardized work packages already established within the work schedules and the integrated mine plan means that all of that tribal knowledge from all of our senior mine personnel that have, developed, incredible skills over the years can be then, transmuted into this software, and then it's always there. And so Tom Vanderberg, the VP of Sibanye-Stillwater, said, there's in mining, there's a high turnover. And he said that what he really likes about having this integrated work schedules is that, new employees can come into the mine very quickly and kind of pick up and go and take the steering wheel and implementing the plan very quickly because of the standardization and all of that information into the software. And digital mines are optimizing the plan, and what they're doing is you're providing a reasonable, a feasible, and a believable work productions schedule that is achievable. And we can apply like these advanced scenario plannings that I was talking about. You can even do that to the work schedule. So we've implemented all the work schedules from all the departments. We can put our optimization solution on top of it, and the software can actually recommend to you multiple variations of the master business schedule that'll be more optimal than what we may have thought as standalone individual divisions making our work plan. So with Sibanye-Stillwater, one of the things that they really liked about it was that now they were seeing that their mine managers were actually, planning differently and problem solving differently. And Rosh Pina said that they felt like this was, a really great solution for them because now with their resource planning, they had it all aligned and they really felt like they were more predictable in their minerals mine, but also in their quality minerals mine. So, there's I could talk for a week just on all the different transformational solutions that mines are achieving using digital, but those are some of the ones that I wanted to talk about today. So thank you for your time.
Thank you.
Thank you.
Let me get your speaker gift. Not a problem. And our final presentation of the session, I'm going to ask Toromont Cat Martin, would you please come to the stage? And just as a reminder, we have a refreshment break at 10:40, about there, but probably take it off at about 10:45 once this presentation is done. And as a reminder for everyone, the buses will be departing anytime after 11:30. Our last panel will be at 11:40 for the keynote session. Thanks.
Hi guys, how are you? Everyone good? Standing in front of you guys in a break, so I'm going to try and keep this right on time. As is noted, my name's Martin Benby. I'm part of the business development team in the mining division, and one of the important pieces that our business development team does is work with our customers to help drive the lowest cost per ton on both greenfield and existing mines. And so one of the functions within the business development team is, of course, we're working with technology and site visits to try and work with you guys all the way through from the pre-feasibility stage all the way to when the mine goes online to help with this. So based on today's audience, I thought it would be interesting to go through a working example of how we use mine planning technology to help, like I say, both greenfield and existing sites to understand the cost per ton and also to play what if scenarios, just to understand the consequences, both positive and negative, when we adjust the fleet size to match production. So we use both software, which we're going to talk about today, which is the theoretical, and our site visits and our personnel to bring our software, the theoretical, to reality on site. Why do we do this? Simply put, the more we can plan and optimize the fleet early, the more accurate our predictions are going to be for cost per ton when you go to market, and of course, accurately keeping your bottom line where you said it was going to be. And then, of course, the when. So, sorry, I'm not clicking here. Sorry, guys. The when. Like I say, we want to engage early. Matt touched on this as well. So really we want to get engaged with your consultants working with your projects, but also the end users of the mines as well. So that usually happens starting at the pre-feasibility through the feasibility all the way through to when the mine comes online. But the key is we want to get at it as quickly as we can. So to get into the example here, so I decided just to grab some screenshots of the software and kind of give a report out. If we got into the actual software, it would just be way too deep and messy. So we'll start with the inputs. Of course, it's the same with anything, garbage in, garbage out. So the more accurate real-life inputs that we can gain from the end user, our customers, our consultants, the better we're going to be and the more accurate we're going to be at giving accurate information at the end. So this is an example of a customer or consultant giving us the material movement that they were looking to achieve over a 5-year period, and based on 5 haul roads there that they wanted to move the material. So they gave us the information on the haul roads and we put it into our system. So here how do we do the laser pointer? Up the top there, of course, an important input, the loose density, the quantity, the amount of material that we're going to move, and then of course each segment of the haul road, including rolling resistance and the grade. So once we input all of the haul roads into the system, we're then going to work to understand and accurately put as much data into both the loading and the hauling tools as possible. Again, there's a lot of data here, but essentially we're able to select box size, bucket size, all the I guess the inputs that would make the theoretical information be absolutely accurate for reality when those trucks and loaders start to produce in the mine site. So what this slide is showing is a combination of the information we got from inputting the haul road information and both the loading tool and the hauling tool. And what we get is cycle times based on each haul road for both the loading and hauling tools. So we can qualify this information. In this particular case, it was an actual existing site, so we were able to qualify the information that was in here to make sure that the cycle times, in theory, match what's happening on the mine site. But in a greenfield application, we're taking our the knowledge that our application engineers have of exchange time, adding it with the information from the haul road profiles, and we do a very good job of getting a very close representation, even though we don't have the ability to test in the field. What I wanted to quickly show here is it's just a rim pull curve, and the key takeaway here is we want to make sure that we build haul roads to match the tonnage for the trucks and the grade, to make sure that the truck is shifting where we want it to shift and staying in that gear on the haul road. Mainly here we're working to protect our transmissions. This slide is just to show that we can predict those things and plan for them, to make sure that we're set up when the mine does get built, to make sure that the loading tool, or sorry, the hauling tools are protected as best we can. Another graph just showing, based on the haul road input, just the speed that the truck will travel over the distance of that haul road. So one of the most important and often underlooked, just one moment here, often misunderstood pieces of information is how many actual work hours are the pieces of equipment working. And so we're usually dealing with 24-hour, 7-day-a-week mines, but when you take out all of the delays in your day, oftentimes when we go through this survey with our customers, we come up with a number that is lower than what they expected or assumed were their actual or their net working hours. And so it's really important when we're working collaboratively with our customers to do this survey and to come to an understanding that in this particular case, although they're running a 24-hour-a-day mine, they're actually only getting 18.8 net operating hours per day. And if you get that wrong, of course, you can misrepresent, especially in a theoretical situation, you can grossly misstate or misrepresent the actual tonnage that you're going to be able to move, and it's just a domino effect from there. So this sheet, although basic, is a very important piece of the inputs. So after we get all that information in, just quickly now we're going to run through the example. So this was a 7-day-a-week operation, like we said, 18.8 hours. They're running 4 crews, and we start to get into some of the results. So like I said, good inputs equal accurate results. So now we can see, based on one of the year's production, we can see tons moved per year, tons moved per day, tons moved per hour. We can see sorry, I don't know how to make the pointer work, but I'll come across. We can see the haul time for each haul road, the fuel burn per metric ton. That's as a group, so that would be the loading, I guess the load haul system. And then the truck hours and the loader hours that are required to move the tonnage for each haul road based on a year. You can see over on the far side all of the truck hours and the loader hours that it's going to take to generate, to achieve our goal. So this is the really neat part about our software. We can start to play what-if scenarios. So in this particular case, the customer wanted to understand, okay, if we use my existing fleet, what's my cost per ton? If we decide to modify the fleet and use 990s and 70-ton trucks, what are the results on my cost per ton? If we use 992s and 100-ton trucks, what are the results on my cost per ton? So we'll just quickly walk through this. Here we've selected the 992 loader at the top, and we've selected their current truck fleet, which was one 777F, one 777G, and 4 70-ton trucks. And what we can see here is we have the CapEx cost per hour, the OpEx cost per hour, the fuel burn in cost per hour, and we can narrow it all the way down to basically $2 an hour. So then we say, okay, well, let's look at a different scenario and see if we can bring that cost per ton down. So with a click of a couple of buttons in our system, we can change the loading tool from a 992 to a 990, and we can move all of the trucks down to 70-ton trucks, and we can see that our cost per ton, in order to achieve the material movement in that particular year, we had to increase the amount of 70-ton trucks to 7, and our cost per ton went up to $220. Then we looked at the scenario, what if we use 100-ton trucks and 992s only, no 70-ton trucks? And we can see that our cost per ton dropped under $2. So far, this is the best scenario. And then we said, okay, what if we use our next gen 992, which has a higher productivity rate, and we use brand new 777s, so basically a brand new fleet, we've increased our availability on the equipment, and we've gained on the productivity of the loader. And we can see that by doing so, we were able to save, based on availability, one whole truck in the run of a year, and we dropped our cost per ton again down to $1.83. So next the customer asks, okay, if that's all fine, but I want to understand an operation only running 5 days a week instead of 7, only running 2 shifts instead of 4. So we put that information in, and what we found is, because of the higher payload on the 992 and the higher availability on the trucks, we dropped our cost per ton by 15 cents. Like I say, we went from 7 days a week to 5 days a week. We went from 2 crews to 4 crews, so we're not operating our trucks as much. We don't have as many people involved. We do need to add an extra truck, but even in adding an extra truck, our loader is still pass matched properly with the extra truck, although right on the edge. We have a higher utilization on the loading tool, and we can reduce our cost per ton by another 15 cents. So this is some of the I guess the benefits of using software mixed with application engineers that have the experience on site. And of course, once we have this theoretical in place and the fleet gets implemented, the next steps would be to optimize on site. So that's another presentation, but we'll just assume that we went ahead with this solution and we deployed a fleet of equipment. Now we come to site and we have the ability to work on haul road optimization, cycle time improvement on the loading and the hauling tools, and tonnage optimization on the loading tools via scale studies, etc. So that's the end of the presentation. I'm out of time, and hope everyone enjoyed that little bit on some technology that we use to help you guys optimize your cost per ton. Thank you.